right, good morning, everyone. We're going to go over today's four problems today, just as another review. So again, all four of these problems are series and parallel combination problems, right? And again, we solve them always by trying to tackle our parallel portion first. So if we look at number one, okay, we can see in number one, the 8 and 16 ohm resistor are in parallel to each other, while the 10 is in series. So the very first thing we're going to do is we're going to solve for the equivalent resistance between the 8 and the 16 using the parallel method. So 1 over R is 1 over 8 plus 1 over 16. That becomes 3 over 16. And when flipped upside down, R is 5.33 or 16 over 3. Sure, I did my math right, actually. Yeah. So that's that. All right, and what that does is basically eliminates the 16 and the 8. It makes a new resistor, which has a value of 5.33. The 10 and this new resistor, as you can see now, are wired together in series. The 10 goes right into that new resistor. So to find the equivalent resistance, it would be 10 plus 5.33, which is 15.33 ohms. And that is the answer to number one, 15.33. Okay. All right. Question two. Well, in question two, we have a parallel circuit. We have branch one, which has a 4 and 5 ohm resistor, and branch two, which has a 3 and 2 ohm resistor. Well, we want to always solve our parallel part first, but we can't do a parallel circuit with multiple resistors in its own branch. So the very first thing we're going to do now is actually turn the 4 and the 5 into one resistor and the 3 and the 6 into one resistor. And we can do that because if we look, the 3 and the 6 are wired together in series, and the 4 and the 5 are wired together in series. So if we do that, basically, we can redraw, and I'll draw it right next to it. The 4 and the 5 become a 9, and the 3 and the 6 also become a 9. So now it actually looks like this, the picture off to the right-hand side. 4 and 5 and 3 and 6 both combine to form 9. And therefore, if we know that, now they're in parallel. So it would be 1 over R equals 1 over 9 plus 1 over 9, which is 2 over 9. So R is 9 over 2, or 4.5 ohms. Okay. So there is number two. Question three. So question three, all right, looks a little weird, but again, it's the same thing. We got to tackle series and parallel. So if we look, the current flows from, you can look where the number 3 is, through the 8 ohm resistor, and then it has a choice. It can go through the 4 ohm resistor and back to the beginning, or it can go through the 3 and 9 ohm resistor. So what we're going to do first is we're going to take that 3 and 9 on the far right-hand side, and we're going to turn that into the number 12, because we can combine those two resistors and make them 12. And now our problem kind of looks like this. 12. Sorry about the glare. So now with the 4 and 12, those two are in parallel. We're going to add the 4 and 12 as a parallel circuit. So 1 over R is 1 over 4 plus 1 over 12, right? Which gets you 5 over, oh, no, 4 over 12. And then we flip it upside down. R is 3, 12 over 4. So far. Well, that 4 and 12 have disappeared and become a 3, and now the 8 and 3 are wired together in series, so the total resistance would be 8 plus 3. So the final answer for this question is 11 ohms. All right, last one. So the current starts where the number 4 is, it goes through the 5 ohm resistor, then it splits, it can go through the top branch or the bottom branch, and then it all dumps back into the 10 ohm resistor. So we're going to first take our parallel portion, which is the 5 and 6, or I'm sorry, the 3 and the 6 up top, and the 2 and the 4 on the bottom, and we're going to combine each one of those, the tops and the bottoms, to make one resistor. So 3 and 6 combined to form 9, and 2 and 4 combined to form a 6. So now it looks like this. We're going to use the 9 and the 6 and add them together via parallel. So 1 over r is 1 over 9 plus 1 over 6. All right, that gets you 1 over r equals 5 over 18, or r is 18 over 5, or, oh, you started there, Ellie? 18 divided by 5, oh, 3.6. So the 9 and 6 have combined to form this 3.6 number. So now the 5 ohm resistor, the 10 ohm resistor, and this new resistor 3.6 are actually all wired in series. So now to find out the total resistance, it would be 5 plus 3.6 plus the far 10, and we do that, we get 18.6. So the final answer to number 4 is 18.6 ohms. So again, as a quick recap, number 1, the answer is 15.33. Number 2, the answer is 4.5. Number 3 is 11 ohms, and number 4 is 18.6. And I just wanted to introduce you all. This is baby Eleanor, Fal, baby Ellie, and I miss you guys all so much. I hope to see you guys again soon. Stay safe, and I'll talk to you guys later.